so 30 minutes, exactly. So, hello, my name is Anton Kotenko. I work in JetBrains for a long time and really happy with that. And today I will tell you something about the long-playing project Noodle that I develop and how my life led me to choosing free monads in the development. Please be aware that there will be some flashing images and videos on the slides and some weird functional code as well. First, I'll tell you why I chose JavaScript, or PureScript, sorry. The Noodle project is the version 3.0 of my previous project written in JavaScript, this time JavaScript, named Reactive Page Development. And it was inspired by different visual programming systems like VFL, the German one, and Touch Designer and Pure Data and MaxMSP in Ableton, and also the popularity of tangible interfaces, which almost became a common thing these days. This is the documentation site, not secure because HTTP, for this project, where you may see many integrated examples and see reactive page development in different visual styles. Yeah, it comes with theming. This is the example of the random generator built with the system. It's JavaScript, so it doesn't bother with the fact that generating random numbers is a side effect, and so should be isolated. Shame. At some point, we used the RPD project to build generative art, and we used its products adapted and polished to match the company brand style in splash screens of your favorite IDEs and to provide you with a full resolution desktop images. Under the hood, the project uses Kefir library, which provides reactive streams, as in reactive programming, which is kind of not that popular nowadays, but left us with several nice ideas to inspire from. At some point later, I discovered Flare project, which amazed me with how reactive programming concepts like streams of data are projected on functional programming. Take a glance at how apply from applicative functor is used to pair to integer inputs that modify the data, like it's just one line of code. Or in this case, the shape is being controlled by sliders using just the applicative pairing. There should be the video, yes. And also it's just a few lines of code. There was also the version of Mario built on signals like in reactive programming. And the code was just 100 of lines with many spacings, like you do in functional programming a lot. And the final function that was getting things into the move looked like this. These three errors are the same as the dot operator in Haskell, just the composition of logic. You remove gravity from the composition, and there is no gravity in your world, and Mario flies into the space. So I decided that I want to know this beautiful language and started to learn Haskell, because Haskell is very close to PureScript, and PureScript is close synthetically to Haskell. But that's a lie. Actually, I learned Elm before and wrote a lot of code with it. And if not Elm, I wouldn't ever understand the concepts of functional programming ever, I suppose. Thank you, Elm. So yeah, then I learned Haskell, and mostly thanks to that only course, and a lot of books and papers and articles, of course, but this course explained me a lot. Unfortunately, it's not in English. Long story short, Haskell is almost like PureScript, but PureScript is better, and for web, haha. So I did some rewriting of the RPD project to PureScript with signals and named it Noodle. The current state of it is located at this address and works with the help of Hydra engine, which is used for generative art and shares the functional programming ideas despite being written in JavaScript. The functions are chained and you get access to the time and to microphone and to audio frequencies, so your visuals may react on music or any sounds, for example. But that's a different story. Yeah. This is the way Noodle looks nowadays in the state of development and the way it interacts with Hydra engine, flashing images, be aware, where every function is considered a node. So let it be to the end, where it becomes more silent. So on the top, there is the palette of nodes you may produce. They're colored differently depending on the type they work with. So that's it. But actually, they are just wrappers for this Hydra engine. That we have some problem. Or maybe at some point it will look something like this, like in terminal. Also fancy, because anyway, it's just the data under the hood. To develop in PureScript, I had to understand how type classes relate to each other. So I made this chart in SVG with the emoji operators. There was some library for PureScript with the operators. You may just use the emoji, for example, the train emoji, to compose functions. And it's fun, really. And there is the second version of it, and then the interactive one, which is not published and not finished yet, but helped me truly a lot just to understand the relations between everything, like monads, monoids, traversables, and everything. Oh, I forgot about the topic of the talk. Sorry, closer to the point. I know there are some debates over those concepts, monad transformers being much more performant in Haskell, at least, but I failed to get transformers well, but succeeded in understanding free monads. And when life gives you no monads, make them le free. The first versions of defining nodes in PureScript looked like this, and the last function here is the last. It is the processing function, taking the inputs of the node and producing the data for the outputs, and close to the JavaScript version, but with types. But every node usually has some state, like gradient here, or the palette, or something, and also produces some effects, like saving a file, or generating a random noise, or the body drawing something on the canvas, for example, like here. So I had this question: what should I do with the processing functions? And I took a look that for rendering I used the PureScript Halgen library, which is somewhat like React but for PureScript. The code of the component looks like this. You have actions, you have the state, you have the rendering function, and something that handles action. And yeah, it's close to the Elm concepts. Yeah, it's just the more detailed another example. But I realized that, sorry, yeah. But I took a look at this handle action function, which every component has to have, and realized that it has everything I need in the node processing functions. You may modify some global state, perform any effects, like remote requests or doing something in JavaScript, because PureScript connects to JavaScript. And when I looked in the source code, it turned out that it's a free monad, as you may suggest, but by the name Halligan M. And so I prototyped the processing functions for nodes. This is where the do goes. This is the processing function, which in this example just takes the values from the inputs A and B and sends the sum of them to the output. This is the interpreter of the free monad, and here A is the free value, so you don't do anything with it, you just pass it everywhere, but it gives you the possibility to make the functor instance, and all of this applicative and monad and everything you want. And M is the monad that is expected to implement monad effect type class. So it doesn't have to be effect, it can also be affect, which is in PureScript like asynchronous effect, so you may run them in parallel and everything. It has constructors for modifying the state, lifting some other monads to it, and also for receiving something from the node input, or sending something to the node output, as for the cases when one needs to send something to the hidden input, for example. The code for running the interpreter will be later in slides. And also I had to rethink the way data is flowing through the node, because the inputs of the node all could receive different types of data, but most of the data storage accessible works with homogeneous data. It's probably getting warm, sorry. And most of the data storage accessible works with homogeneous data like arrays, lists, or maps, where every element there should be of the same type, like only array of integers, or map that stores only strings or something else. But anyway, and on the contrary, variants and records in PureScript are built using their own system of row types, where every label is bound or paired to the specific type. And you may ask if the type stores the value you need of the specific type bound to the corresponding label. So for example, the variant is like either it has the integer value at the label of foo. And the record is just like record in JavaScript, but with types. So this way you ensure that it has the field foo, which contains the value the integer value. But due to this, due to the fact that they are heterogeneous, you have to use different ways to fold all these data types, and this is a bit more complicated. But anyway, yeah, I decided to use the records, for example. This is the way the API user may define the nodes using records now, and everything checked at the compile time. So if you write something that doesn't exist in the definition of the node, the compiling will fail and not the runtime. This way, you may be sure that everything works together. And this is these values of the input. It may look complicated because the fn.input is the constructor, and the fn.input with a, it is actually the type, not the value. So that way, because this symbol, they call it, is stored at the type level, the compiler may ensure that the record has the field of a, and it's always integer, and your program fails to compile, not failing at runtime, because and so the toolkits are defined this way. A toolkit is the definition of families of nodes. Like the family of nodes is, they're all similar. For example, all the nodes that produce noise are, some Perlin noise, for example, are from the same family of noise. The downside of this is that you always have to specify the type. In PureScript, it's usually compiler may suggest the proper type for you, and you don't have to specify the type. But mapping and folding over records is harder to figure out for the compiler. So due to the fact they're heterogeneous. So this way, but anyway, you will store it in some separate modules, something like that. And this is the example of the node that performs some side effect. It has just two inputs and does this effect and lifts it to the monad. And there is the shorter syntax with underscore, not to write the fn input every time. And you may also store the type value in some variable, not variable, immutable variable. And this is the final version of the free monad interpreter. So these E's and O's are inputs and outputs, and they are both row types. These are the functions that may be called from the body of the do notation of the monad. Notice the use of the const constraint. It ensures that there is an inlet input by that name that receives this specific type of values, or the outlet or output of this of that name that may send the specific type of values. And here's the function that runs the interpreter, just to illustrate how considerably easy it is to write. Also, since you may perform any effects here, you, for example, may encode any action you perform to JSON, for example, or any data storage, and store it in some file, like how everything was performed state by state and step by step as well, and then reproduce it, for example. I hope now you see how free monads are cool, or became much more convinced to use them than before. So feel free to investigate the code. That is very messy for the moment, being in rush development to get some nice result. So this is the end. Thank you. And someone, Eugene, suggested me to suggest the date of the next meetup to be, for example, the 16th of March. Please come. I don't know where it will be and what talks will be there, or maybe there will be just Stammtisch, sorry. But yeah, thank you.